You see, you're media director for this. Thank you very much.
Why you pay me
That's
the
why
big
video
bucks?
director. Yeah, good. Exactly. Yes, I'm fine. I think I'll go right. Bob is here. Thank you.
Привет.
Okay, let's get started. Hello, this is a six-man working group. Just to check in. I see familiar faces, but just in case, if you're in the wrong room. So, we have 2 hours today. We have Bob remote, me here, and Uli very, very remote, so he couldn't even join us. So, note well. Please take a few seconds to read it if it's the first time you see it, or maybe even if you see it before. It's like airlines, right? They always ask you to check the safety card, even if you're a frequent flyer. So, housekeeping. I was going to say please wear masks, but everyone doing it anyway, so great. So please, if you're joining the queue, being in the room, please still use on-site tool because it would make my life much, much easier in terms of queue management. And state your name at the microphone. David, who is taking minutes, will greatly appreciate that. And try to leave the queue when done. I personally keep forgetting that, but still. And remote participants, please keep your video and audio off until you start speaking. And then please use headsets. So.
And we also, if I can just add one thing, the chat seems to not be working. So.
Yeah, as Eric confirmed, it looks like individual messages work in the Meetecho chat, but you cannot send messages to the group chat. Thanks, Bob. So here is a link to the agenda, which has all other useful links there, like to the slides, meeting materials, chat, and so on. So agenda, busy one today. So we have approximately 65 minutes for working group documents. We have 4 drafts. Then we are going to spend another 45 minutes on individual documents. And we also have some time permitting with no time allocated. But I don't know, maybe we can done with all working group business so quickly so we can have some backup presentations. Yeah, we got like about hour and a half more requests than we can accommodate. So what's happened since we met last time? We published an RFC on OM in segment routing. Minimum pass MTU hop by hop option is an RFC editor's queue. We have about one tricky document, and I'll have another slide just for that about alternate marking method. And there is a document which makes me feel guilty because I'm still working on the write-up. It's a 6874 bis. So it hopefully will be out for AD review later this week. And yeah, and as I said, we have 5 working group documents. 4 of them will be presented today. And one which is actually dangerously close to get expired, but I have not heard from authors yet. So the last of the chair slide. If you didn't pay attention to the mailing list, we had an interesting case when a document was adopted by the working group, went through the working group last call and the IETF last call, and was reviewed by ASG, but then quite late an APR disclosure was made by one of the authors. And some requests were made, some comments were made about shall we consider it as a significant change to the document, or at least something which working group needs to be aware of and decide if we still have consensus on proceeding with the document. So Altmark document was returned to the working group at the beginning of July. And the chairs believe that there is still consensus. Few comments were made, but it looks like there is no violent disagreement on proceeding with the document. So just today, after some delay, yeah, I updated the thread. So I think we're good to proceed with that one. But to the all authors, please, if you have an IPR disclosure, we'll really appreciate if it's done before the document is out of the working group. So I think that's all of the chair slides. Any like last minute comments to the agenda or nothing? Great. So I guess our first presentation today is Suresh with the segment identifiers. I am going to share.
Thank you, Jen.
Next slide.
Yeah, thank you. It's really my only slide, really, but I'll try to keep this very short. So this draft has been adopted like at the last IETF meeting and confirmed on the list after. And there were a bunch of comments. So some of them just editorial. There's also some substantive comments. And they've all been addressed in the 01 draft. So one key thing that came up was like a slight wording confusion in the IANA consideration section. So I had used the word global unicast, right? And people some of the like RIRs were like a bit confused that this is going into territory that the RIRs like kind of like allocate from. So kind of reworded the whole thing to say this is not coming from the RIR allocatable space, but instead it comes from the IETF resource space, right? Like, so that's like one major thing. And thanks Jen, George Michelson and Ted who kind of iterated on this so I can come up with the like right change there. It's a very small change, but it's very important because it clarifies where the space comes out of, and then we can define the properties of the space. And another thing is like from Darren, because I was talking about stuff changing on the fly, right, in transit. And one key thing was like it only changes at what could be a segment endpoint, so it doesn't change willy-nilly at any transit point. So I think that's something. It has a little bit of loose wording on my part, and Darren pointed that out, so that's fixed as well. And the last thing is like either you can think of it as 1 point or 2 points, but it came from Brian, right? Like, so this whole thing started like thanks to Eric and Joel. It started with like a request coming from Spring to Sixman, right? Saying, hey, write up like this thing. And so we've done that. And as a result of writing this stuff up, there's some actions that need to be performed in Spring at some future point. So we need to kind of close the loop on this, tell Spring that, hey, you asked us to do this. We've done it. And by the way, there's also other stuff for you to do, right, as a result of this. So that's something we probably need to craft an official message like Jen, Bob, and Ola when he comes back to get that message out to Spring to kind of close the loop on this. That's pretty much what's in there. So there's like no pending comments on this. So if you have any comments, like please feel free to bring them up here or on the mailing list after, and I'll be like very, very quick to kind of make the changes that is required. And let's go forward with it. So next slide, Jen. Yep. So if like, something is going to hold, unless something holds it up, like it'll be, I think the document is ready for working group last call. So I would officially request the chairs to go for like working group last call on this, pending some hold down timer after the meeting. And also to write up something towards the Spring working group. I know Joel is here and Jim is here as well. So like, but to write something up officially towards Spring to say like, hey, we've done this, please look at it. And they can forward the mail to the group and go from there. So, thank you.
Yeah. Any comments, questions? Silence. Sounds like consensus.
Silence.
Oh, Eric.
case of the battery dead mic.
It was just off.
Yeah.
Air client. So I guess I was going to try to channel Andrew, who's not here, and ask about whether or not the what people think about the /16 being a must not in the DFZ.
Okay, so if you look at the draft today, right? So the idea is like, so one of the actions that's for Spring. So if you can go back to the previous slide, right, is to do the operational guidelines for the 16 as well, right? Like that, like Spring needs to develop. So the idea would be some operators who are deploying this would write that up, and I'm perfectly fine with that, right? But that's, I think that would be a fine thing to write somewhere, right? Does that belong in this document? I don't know, right? Like that's, I think it's open to discussion. So if you want to put that in here, that's fine. If it's going to go into an operational guideline document, that's fine too, right? Because the goal is for somebody to be able to filter it, right? Like so, and if you need like a stronger recommendation somewhere, that's fine. Like, yeah, so if Andrew's like puts that up, I think we can certainly work on where we need to put it in.
So maybe we just put that in the communication with Spring.
Okay, cool.
Yeah.
Thanks.
Okay, so thank you, Suresh. I think we'll issue the last call after this meeting. So sometime probably early next week, maybe this week, yeah. And yeah, we'll take care of
Not this week. Like I know you're like stressed, so next week is good. Thanks. Thank you. Thanks, Jen. Thanks, Bob.
Okay, thanks.
So,
Okay, and the next presentation is Hop by Hop processing procedures. Gore, are you going to share the slides or you want me to present?
Hi, I can ask. There we go. That work.
Okay, sorry. Yeah.
Hi. So this talk is traditionally done by Bob and I as we move between a square on the ground and the IETF. Both of us are remote this time, so we'll do our best to be brief, but we'd like to tell you about the updates we've done to the hop by hop options processing procedures. Bob will chip in as he needs to. So the previous version was working group 00, and we were working our way through a large number of adoption questions, comments, and other feedback. And we made a number of updates that are present in the 01 draft. We added text to section 1 to make the focus clear. We're setting a minimum bound in this document for what we hope to see actually deployed in equipment, what we hope to see the end systems being able to use across an IPv6 path. And this doesn't necessarily control anything about what you might do more than the minimum. We added text to section 4. We said that some options will be supported internet-wide and others might not be in limited domains. We added some references and clarified the H200 comments, fixed a typo, and then importantly changed the should not from a must not. And if you really cared about issue 21, you will realize that that is what people were asking for when we did the working group adoption. So I think that is a summary of what we changed. Is that okay, Bob?
Yes.
So I guess the other thing we should say is we have an issue tracker. It's the 6-man tracker, and we're trying to recall issues for this draft in that issue tracker. There were 21 issues when we started this from the adoption call, which was a very healthy group of issues to address. There are currently 9 open issues, so I'll talk through those. The 9 open issues actually relate to fewer than 9 points. And this is our summary. The first one is, what status will this internet draft have when it's published as an RFC? It probably was difficult to judge that at the beginning. Now it's maturing. You might want to try and help us figure this out. Should it be a BCP? Should it do requirements? Or simply be informational? Might be good as a BCP, perhaps. I don't know. And please tell us, because we really would like to know what is best. Issues 9 and 15 relate to router alert, or the router alert option, which was mentioned a number of times. It is a hop-by-hop option, and we're expecting this to be tackled by another internet draft in 6 months. So hopefully we can clear this issue by saying another draft will talk about this. Now, the most exciting thing of all, what do we call it when a router processes a hop-by-hop option as part of its forwarding? It could be processed maybe in software. It could be maybe processed in an ASIC. It could maybe processed in some offloader or machine engine. We previously called this slow path and fast path. People hated that because they said it referred to a router design rather than a way of processing. So we now talk about processing extension headers, particularly hop-by-hop headers, at full processing speed. We think that resolves the issue of talking about slow path and fast path. But to believe that we solved it, you'd have to read the text and tell us that you like what we've written. I'll talk briefly about number 8, which is lack of graceful handling of malformed extension headers. We think this is a security issue. We'd like to add some text and security considerations for this. If you care about malformed extension headers, please help us write that text. We think it's more or less the same as any other malformed header. If you write bad router code, then your routers will either crash or behave badly. If you write good router code or protect the code, then you don't have a problem. Doesn't seem like something new for hop-by-hop options. RFC 9098 talks about processing the payloads of IPv6 packets as you forward them. And again, if you're interested in this topic and think there is good text on that, please tell us. It doesn't particularly relate to hop-by-hop options, and it may perhaps be something to mention in security considerations, since this is commonly done by firewalls and other middle boxes. We don't have any ASIC experience. Well, I don't. I don't think Bob has either. So if you know about what ASICs are actually deployed in new equipment and want to talk to us, please do. We would love to hear you. We will be influenced by people who tell us that they are deploying things at scale, that do things, that need things to happen. So talk to us, please. If you're thinking about having extension header support for hop-by-hop options, we'd love to hear from you. And the last one was a comment I don't know what to do with, so we will leave that on the screen as issue number 2. So that was my quick tour. And we really do want people to read the document. So the first thing we'd like you to look at is whether we have eliminated the definition of fast path and slow path and replaced it by something useful talking about full forwarding rate. Please read the draft. We think this issue is solved. We'd love to hear people's feedback about whether we've got good language here or suggestions of something better. I talked about this. I think it's a security consideration. If you agree, please tell me. If you disagree, please tell us both. We talked about this. We don't see this as a particular issue. If you think it is, please talk to us. So what are the next steps? Well, if we've actually resolved the issues we've talked about, then our document is either ready to decide its standard status and publish as a via a working group last call, or it's time for people to tell us that there are more issues with it. Either way, we're looking for reviews of our document to revise our ID. And I think that's our slide deck. Any comments or questions?
Fernanda?
Yeah, hi, Gori. Well, I haven't looked at the document for the last something, month. But if you need a review, I can volunteer to do another review of the document.
Well, if anyone offers to review, that would be great. And Fernando, you asked some of the questions I've just put up. So yes, please give us feedback on whether we're making progress and suggest more text for the pieces we need to solve. Wonderful.
Yeah, I think I would add particularly, if you see an issue in this document, please suggest text to how to resolve it. That's very helpful to us.
Okay, so yeah, please read the draft. I think we should have some discussion on the list, and yeah, based on that, then decide after closing those issues. Yeah, we can discuss the last call. So, any more last minute comments, questions? We're doing well today. Hello.
Thank you.
Okay. Thank you, Gori. Okay, and the next presentation is Fernando. Improvement to stateless auto configuration.
Okay. Can you show the slide from there, Jen?
Okay, yeah, if you want me to, yeah, sure. I'll share the slides. Just a second.
Okay, so hi all, this is Fernando Gont. I'll be doing the presentation on the document Improving the Robustness of Stateless Address Auto Configuration to Flash Renumbering Events. Next slide, please. So super, short background. Essentially, this is a topic that we have been working on for, a couple of years now. There are a few documents that some of this work has been carried out in the B6 group. So we have RFC 8978, which is essentially the problem statement document. Then we also produce RFC 9096, which is recommendations for customer edge routers. And finally, this is the last remaining item, this document that I'll be presenting today, which is protocol improvements to actually improve the handling of flash renumbering events. Next slide. Okay, so a few comments about the progress on this ID. So essentially, what we have been doing is incorporate the contents of the individual submission. First comment is that I recently, last month or so, polled the 6-month working group about 2 specific items. We have received some comments on those, but if for some reason you have missed them, please, feel free. I will send an email to the mailing list to highlight the threads. So if you have comments on those 2 topics, please do send your comments so that we can address them when we produce the resultant text for the document. And there was only a single topic or issue to address, which was the that of incorporating the algorithm to with heuristics to deprecate stale information. What we have done is to produce I would say a simpler and more robust algorithm from what we had in the individual submission. And the goal of this presentation is essentially to describe the algorithm from a conceptual level. And afterwards I'll be sending the draft text to the mailing list for specific review of the text. Okay, next slide, please. So what's the idea? And actually, this slide makes it look like more complex than it actually is. So what's the basic idea of this algorithm, the improved algorithm that we have produced? So the idea is super simple. If your host receives an array that contains missing information, so it's lacking information that was received beforehand, what we want to do is to poll the corresponding router with a unicast router solicitation to double check if the information is there or not. Okay, Then based on the result of that, we can decide whether, yeah, the information was there and we can, keep the information, or actually no, the information has become stale, so we should, get rid of it. This slide just makes the process or the algorithm more, it just addresses details. So we start at the beginning when an array is received. Okay, we are considering arrays that are missing information that have been previously received from this router. Okay, so if we have one of those cases, then we will wait for some time. This would be like a couple of seconds, because it could be, in theory, doesn't happen in practice, but could happen in theory, that the router is splitting the Slack information into multiple packets. So we will wait for some time here. Then if that information hasn't been received, what we do is just wait a small random period of time. That's just to avoid a lot of hosts on the same network to poll the router at the same time. That's the random wait that we have there. And then what we do is essentially just poll the local router with a unicast router solicitation. What we do by default in the algorithm is just poll once, but it's up to the implementation. You could poll multiple times, send an arrays. If you don't get what you want, you poll again, and so on. If when we get to the RS prove timeout here, by the end of the yellow graphic, we haven't received the missing information from the router. So that means that the information has become stale, okay? And what we do is essentially remove that stale data. So in the next slides, what I have is essentially like the same graphic, but an analysis of typical scenarios. So next slide, please. So this is the most usual case. Nothing bad is going on. So we just receive an array with all the same information that we had received before. Okay, everything's okay. There's nothing to do. There's no missing information, nothing to trigger there. All information is fresh. Next slide. Then we have the case of fresh data, but with the corner case, theoretical corner case, where the router splits the Slack information into multiple packets. Again, I've never seen that, and I don't know anyone that has seen this in practice, but in theory, the specs allow it. So what we have is we receive an array, the first one, okay, that doesn't contain all the information that we had previously received from this router, okay? So we wait for we enter this algorithm, and the algorithm says, okay, before you poll the router, before trying to poll the router, just wait for some time, because the information might arrive in a separate array. So we wait for some time, and we indeed receive the array with the missing data, okay? So again, all the information is fresh. There's nothing to do about it. We are okay. That's why we have the, the green stuff in there. Next slide, please. We have another, this is again, corner case. We are just trying to be super robust. We have again, the corner case where we have a router that is spreading the Slack information into multiple arrays, and there's also packet loss, okay? So some of those arrays with partial information might be lost. So we start here with an array that contains partial information, and when we receive that array, we say, okay, well, partial information, we need to double check if the rest of the information is there or not. We wait for some time, we wait for the missing data, but one of the other arrays just got lost, okay? So what we do is we do a random wait. This is just a few seconds, random value of a few seconds, and then we decide to prove the router with the unicast router solicitation. This is when we enter the yellow stuff in here. So we send the proof to the router responds, and we do receive the missing information. So all the information has been refreshed, nothing else to do, we are okay. We enter the green stuff again. And last slide, next slide, sorry. Well, next slide is exactly the same. So we receive an array with partial information. We wait some time to receive the missing data. We don't receive it. So we say, okay, time to poll the router to see if the information is there. We do poll the router, but we never receive that missing information. So after polling the router, in our case, we poll the router just once, a single RS, but it's configurable. You could request that the host polls the router more than once. Once we get the response from the router, from the advertising router, if the information is not there, we say, okay, we hadn't received the information before. We poll the router is still not sending that information. We consider the information has become stale. So we disassociate that information with the router. Okay. Next slide. So that's the algorithm. It's simpler and improved over the version that we had for at least two reasons. First one is that in the previous algorithm, we were, we had to modify, the timers, for example, of the options, which that made the algorithm more complex. That's one thing. And the second thing is that the principle here is super simple. If there's information that is missing, what we do, we poll the router with a unicast router solicitation and wait what comes back. If the information doesn't come back, well, it's not there. And so the principle is simple and obviously more robust than the previous algorithm. So we will send the text for the algorithm to the mailing list for review. But I'm wondering if there are any comments or questions about it.
Tommaso?
Yep. Tommaso Pecorello, University of Florence. Just a quick question. What if the information keep being sent and being lost? I mean, suppose that super corner case of a router that sends the array with 2 or more packets and it keeps sending the information upon a router solicitation unicast, and it keeps being lost sometimes. I think that we need a number of retries time after which it is given up altogether.
Yeah, so the algorithm does consider, that of the number of proofs to be configurable. So I would say that, Slack anyway assumes that, if off the top of my head, like, 3 retransmissions, and, if after you retransmit 3 times, things don't work, well, Slack will break anyway. But so if we wanted to fail on the safe side, we could, instead of defaulting to a single proof, we could default to 3. That's in the document already. It's just, changing the default value from 1, which is what we have right now, to 3. But it's a valid point.
Tim Winters, QA Cafe. My question would be, do you want to send the multicast array out at the very end before you get rid of the info to make sure there's nobody out there that might have no router out there that might answer you?
No, because you do this on a per router basis. So thinking from a multi-router, multi-prefix point of view, what you do is you don't remove the information altogether, but you disassociate that information with that specific advertising router. If there's any other system that is advertising the same information, it's okay. So you will keep that other part. It's just disassociating the information with that particular router. The only case in which you end up completely removing the information if there was a single router advertising the information.
Yeah, I guess the only case there, would be failover. Okay.
Actually, yeah, no heads, just Janinkova. Just curious, yes. So I also was going to ask, was Timothy asked about sending maybe all routers RS, not unicast, because it might be a corner case when your link local address of one of the routers changed, but the information PIOs advertised by that router is still the same. So in this case, I guess you would not see it yet. For example, maybe you have not received an array from that router, but you would not ask that router at all, right?
But at least my expectation would be that when, and that is according to 4861, that if the router, for example, change the address and it becomes an advertising router, it will multicast the information, and actually a couple of times from as soon as it joins the network. So you should have received that information too.
Okay.
But it's something that we could do anyway. I don't mind doing that. I don't mind.
Okay, and the second question, I'm just curious. So, remind me, when you say you remove dissociate outdated information, you mean make the address invalid or deprecated?
So in this case, what we do is, first of all, we don't say we eliminate the information. So what we say is we don't consider that this information has been advertised by that particular router. Now, assuming that a single router was advertising the information, to go back to your case, what we do is we would end up removing the addresses, okay? Because we are proving the router, okay? So it's not that just we are proving the router is responding, and the router is not advertising the prefix anymore.
Okay, so any existing sessions which are happening between devices on the same link using that address will be disconnected, right?
If that is the only router advertising the prefix, yes.
Like I'm just curious if there's any strong reason to do that, because if you have like session between two devices on the same link, you're basically breaking it while the session could have survived.
Yes, but I would say that is a side effect when you are using essentially provider dependent prefixes for local connections. So I would say that's the case. And the reason for which it's a valid point to to reevaluate. The reason for which we suggest to remove the addresses is that the router is responding, so it's not that it's dead. It's responding and not sending the prefix anymore. So otherwise, you would be dragging information that has become stale. It's not that there's a transient problem with the router that is not responding. It's responding and not advertising the prefix.
Cool. It's the very last question. So not responding means there is no PIO, or PIO with preferred lifetime or valid lifetime 0. Preferred lifetime 0, more interesting corner case.
It means the router is responding, so it is sending an array, but it's not including the PIO that had previously been advertised.
Okay, so
which
it
is the
doesn't
case.
matter. So like preferred lifetime 0 in that PIO will be still counted as advertised. Just curious.
Yes.
Okay, thank you.
Yes.
Bob, you were in the queue, no? Oh, you disappeared.
Yeah, I was just going to ask that, based on, I think we asked Fernando that he said you've never seen a case of a router splitting information over two RAs. So based on that, I wonder if it's necessary or how useful it is to have the case, to include that in this document.
So it is included. So we haven't seen that case in practice, but still the algorithm accommodates that case. So the algorithm is robust in that case. So we don't react right away when you receive an array with partial information, but actually wait for other possible arrays containing the missing information to arrive.
Okay, thank you.
Okay. No.
Okay, I send the draft text for the algorithm on the list. That in these slides we cover the let's say the concept of the algorithm. I will send the text so that folks can look into more detail and provide feedback.
Cool. Eric?
Eric, yeah. So I assume this is like section 4.5 that says TBD. Yeah.
Yeah.
Can I ask whether your proposed text is largely narrative, or will it be framed will it be framed as a state machine, particularly the state machine that needs to be implemented to keep track of this?
Yeah. I have the text already. I can send it right away.
I was just going to express a personal preference. I don't know about anybody else, but a personal preference for like a describing a state machine operation.
Okay.
I think it'll be, yeah. Thank you.
Okay. Any more questions? Okay, good. Thank you, Fernanda. Looking forward to seeing updated version.
Thank you.
And the next presentation is covering VTP information extension headers. Okay, Jidong, are you going to share the slides or you like me to present?
You want me to share my desktop or from
Up
the
to
system?
you, like you can request sharing slides or I can do that for you and you'll just ask me to move forward to the
Okay,
next slide.
maybe you can help to share it.
Okay.
Thank you.
Yeah, I can do that.
Yeah, okay. So, hello everyone. This is Jidong from Huawei, and I'm going to give an update about this draft on carrying the VTN information in the IPv6 extension header on behalf of these co-authors. Okay, next slide, please. So here are some background and the current status of this draft. Basically, this document introduced a new hub-by-hub option to carry the VTN information in the IPv6 packet. It is used by the transit nodes on the path to steer the packets to the set of network resources allocated to a VTN. We received comments during and after the adoption call, and this shows there is interest to make this option generic and more flexible. So in the last IETF meeting, the authors presented some considerations about the extensibility of this VTN option, both in the semantics and also the format. So in this 0.1 version, it reflects the update to the format of the VTN option, while the generalization of the semantics may need some further discussion in the working group. Okay, next slide, please. Here we show the updated VTN option format. Basically, it consists of the option type, option data length, and the flags field, the reserved field, and the Vtn Resource Id field. In the option type field, the first two bits are set to 0 so that it is ignored when it is not recognized in the packet forwarding, and it is not should not be changed in the packet forwarding. The option data length is set to 8. It reflects the length of the data fields. Here we introduce a flags field, and one flag is defined in this version. It's called a strict match, which means that when a packet has its S flag set, it must match with the VTN resource ID, which is configured on the outgoing interface for the packet forwarding. Otherwise, the packet should be dropped. And if the S flag is set to 0, it means that when there's no matching of the VTN resource ID on the outgoing interface, the packet will be forwarded using the default set of resource on the interface. The reserve field is left for the future extensions to this option, and the VTN resource ID is a 4-octet identifier of the set of resources allocated to a VTN. So with this format, we keep the VTN option with a fixed length and also left rooms for the future extensions. Okay, next page, please. Okay, here are some other updates in the 0.1 version. First, we clarify that the VTN option can be used for network slicing and could also be used for other application scenarios. And in the context of network slicing, the VTN and NRP, the network resource partition, are similar concepts. It also clarifies that the relationship with the 5G network slice identifier, which is SNSSAI, basically in the 5G network slice scenarios, there may be a mapping relationship between the SNSSAI and the VTN. We also update the forwarding behaviors, which takes the S flag, the value of the S flag into consideration. There are also some editorial changes in this version. Okay, next page, please. Okay, here are the next steps. We would like to collect the further feedbacks from the working group. And if there's interest, we could continue to have the further discussion about the semantics generalization. Then we will update the document accordingly based on the comments and feedbacks. Thanks.
Okay. Eric.
Eric Ving Cisco, no specific head. Again, I keep repeating myself on this specific draft, but having a fixed length option for just a single use case is a kind of a waste of the code space. I would prefer very much to get a variable length color thing that could be applied to many, many use cases.
Yes, thanks for your comments. We noted your suggestion about the variable length. Well, we also see that in the hop-by-hop processing draft, it recommends, or the rule in that draft is that we should use fixed length options for hop-by-hop header. So maybe we need to consider whether we need to align with the rules in that document. But I agree, we need to make it extensible. That's why we introduce some new fields and maybe and not limited it to the natural slicing use case. Yeah, that is for sure.
Thank you, Joe.
Joel Halpern with Ericsson. I think that your intention in the wording was to meet some requirements that you and I have discussed and the working group has discussed in the past, but the wording left me a little confused. You sometimes talk about this field as a VTN ID. You sometimes talk about it as a VTN resource ID. I hope it's the resource ID, i.e. it's an aggregate that represents a resource allocation to meet some set of traffic, which may be a collection of VTNs or whatever. At which point the other thing is, then I think that means the same thing as the NRP, the network resource partition that's discussed in T's, and we should make clear the relationship. And that's the really important part. We should make it clear what we're representing, whatever it is, please.
Yeah, thanks for your comment, John. Yeah, I agree that we have been discussed about the semantics of this ID, and we have made it clear that it is the resource ID, VTN resource ID, or we may call it NRP ID for in the context of slicing. But you may also know that there's the suggestion about the generalization of this semantics of this option or the ID. So we are open to some further comments about the generalization, and maybe it is not reflected in this current version. We are still using the VTN resource ID here, but we may consider whether there's other suggestion to make it more generic in its semantics. Thanks.
Okay, I do not see anyone else in the queue, so thank you, Joe.
Yeah,
I
thank
guess
you.
we shall expect an updated draft based on the comments you received today and on the list, right? Okay, now we are moving to the individual drafts on the agenda, slightly ahead of time. Great, so we might have more time for discussion for them. So I'm going to share the slides for ICMPv6 extensions for IAM discovery.
Okay.
Okay.
Thank you.
Xiaomin,
Thank you,
your
Jay.
floor is yours.
Okay. Hello, everyone. It's Xiaomi from ZTE speaking. This presentation is on ICMPv6 echo request reply for enabled in-situ OEM capabilities. This is the second time I presented. Next slide, please. This is the recap of this draft. This draft defines ICMPv6 extensions to achieve IOM capabilities discovery in IPv6 networks. This draft is a companion document of draft IETF IBPM IOM conf state. This draft defines two new ICMPv6 messages called IOM echo request and IOM echo reply. For ICMPv6 IOM echo reply, 6 IOM capabilities objects are defined. There are pre-allocated tracing capabilities object, IOM incremental tracing capabilities object, IOM proof of transit capabilities object, IOM edge-to-edge capabilities object, IOM DEX capabilities object, and IOM end of domain object. Next slide, please. This slide shows the status of the draft IETF IBPM IOM conf state. This IBPM document defines a general method of IOM capabilities discovery, allowing the IOM encapsulating node to discover the enabled IOM capabilities of each IOM transit and decapsulating node along the transport path of IOM data packet. This draft has passed the working group last call in IBPM working group and is currently with transport AD. The general method defined in that IBPM document can be applied in IPv6, MPLS, SSC, and BEER environments. Next slide, please. The 0.0 version of this draft was presented at IETF114. Some good discussions happened there. Here we list a few updates since then. Firstly, one more example where two namespace IDs are deployed was added. Secondly, the encodings of IOM echo replies examples were updated to align with the IPPM document. Thirdly, some editorial changes were made and the needs were fixed. Note that one more need in figure 6 will be fixed in next revision of this draft. Next slide, please. Next step, the authors ask the 6-man working group to consider adoption of this draft. Thank you.
Okay. Comments, questions, suggestions? This room is very quiet today.
In the chat, Eric asked whether node information queries could be used for this.
Eric doing Cisco, no head, and thank you both for picking the point. I'm a little bit annoyed by using an echo request reply for such information. There is an experimental though information node query, and I would kind of prefer and find it more logical to define a new ICMP code or type, I never know which one to be used, for this rather than echo.
So do you ask me to compare the ICMPv6 and node information queries. Is this your intention?
I would prefer to use something else than an echo request reply to convey this kind of information.
But in IPPM document, we have defined that we need to use echo request reply to convey the IAM capabilities.
Okay, anyway, let's continue over email, maybe.
Yeah, I think it's because audio might not be working very well. Yeah, so let's
Yeah,
take it to the
but
list.
but I think I think I tend to agree with Eric. I think it's definitely worth looking at because that's a structure that could be used for other kinds of queries, including this one.
Okay, but we can discuss it by email further.
Good.
Thank you.
Very good.
Okay, thank you, Xao. So, Eric, I'll delete you from the queue. Yeah, fine. I just wanted to make sure you don't have more questions. Okay, so next one. Okay, I'll share the next set of slides for you, Xao. It is upper layer checksum. Okay.
Okay, thank you, Jen. Hello, everyone. It's Tommy again. This presentation is on SRv6 upper layer checksum. This is the 0.0 version individual draft. Next slide, please. This is the problem statement of this draft. In SRv6, when the last seed is a compressed one, the upper layer checksum computation rule defined in RFC 8200 doesn't apply anymore. Here we provide two examples when RFC 8200 doesn't apply. The first example is the next seed flavor of compressed seed. Multiple seeds may be carried in the IPv6 destination address at the same time. The second example is the replace seed flavor of compressed seed. The last element of the routing header may be not a 128-bit address, but a 16-bit or 32-bit compressed seed. Next slide, please. This slide demonstrates the proposed solution in this draft. Firstly, it keeps RFC 8200 as is. Secondly, it inserts a 128-bit address of the final destination into the last seed, using a new SH flag to indicate the insertion. Thirdly, the pseudocode on processing the new defined SHC flag is copied here. Please review the pseudocode after the meeting. Thank you. Next slide, please. During the discussions on and off the mailing list, two other proposed solutions were raised. The first one is to standardize that the last seed must be uncompressed, and then keep RFC 8200 as is. The second one is to require that at the originating node, when the last seed is compressed, decompress it, and put the resulting IPv6 destination address into the pseudo header for upper layer checksum computation, and then update RFC 8200 accordingly. Next slide. Next steps for this draft, the authors ask for more review and comments and expect to converge on one solution. That's all. Thank you.
Darren is in the queue.
Yeah, Darren Duke, Cisco Systems. The SR source knows the destination, whether it's compressed or uncompressed, doesn't matter. By the time the packet reaches the destination node, the destination address is in the destination address field and is used for upper layer header checksum calculation. I don't think there's any need for this draft. It works as is.
This chapter, in this chapter, we have the problem statement. That's mainly because in RFC 8200, it's assumed that the last seed is a 128-bit IPv6 address. So at the originating node, we need to have that kind of last seed. Otherwise, the checksum calculation is not applied. It's not aligned with RFC 8200.
Yeah, and I'll say I think that problem statement is wrong.
Darren, maybe if you can put your comments on the list.
I will, thanks.
Yeah, so we can continue discussion on the list on this.
Yes, thank you, Darren.
Okay. No more comments or questions. So we then move to the next draft. Paolo, are you in the room? Ah, great.
We switch to somebody in presence.
Okay. You could sit in front of me.
Right, okay. So good afternoon, Paolo Volpato. I'm with Huawei, and I'm presenting on behalf of my co-author, Edward, which I guess is connected remotely. So just to give you the background for this draft, we developed some time in analysis on neighbor discovery protocols and the role of ND to keep with to handle, let's say, the prefix robustness cases. We decided then to, let's say, narrow down the scope of that old draft and move to this one, which is basically the role of neighbor discovery in multi-homing, multi-prefix networks. Next slide, please. Well, there is no need to discuss what a multi-homing, multi-prefix network is. There is one example here in the picture. You see basically something that sometimes is used for small offices, home offices. I would say this is specifically useful for, say, small or medium enterprises. You have, for example, two routers, two CEs connected to two different providers. The reason for that is to, let's say, provide resilience or, let's say, support load balancing or whatever other applications that are useful for an enterprise. The topology, the architecture of the internal network may be quite complex. So this is, let's say, the main reason. There is a lot of literature that has already described these cases. So how to, let's say, deal with the different connectivity cases or the lack of connectivity because of faults. You see some example there, site topology discussed in 7157, which is the, I would say, the original RFC to discuss multi-homing without net. There is the 8678, which is the full analysis on the requirements and solutions for the usage of multi-homing, multi-prefix networks, especially for enterprises. Let's say that to grant connectivity there, we have to solve a few issues, I would say. So we have to solve a few problems. You see, they are listed here. Choose the right source address, choose the right next hop. And then there is also a third problem, which is not addressed by our draft, but that is, let's say, how to provide connectivity, to guide connectivity, to steer the packets across a, let's say, complex topology using source addressing or source routing. Again, if you look at the available literature, the cases for that are almost solved, I would say. There are problems still to be addressed, but let's say most of the mechanisms have been addressed. You see, for example, 8028 and again 8678. Now, for the open cases, so we have focused our analysis on the role of neighbor discovery. So once again, 4861, 4862, and the default address selection, because the mechanism to decide the source address and the next hop is defined by 6724. Next slide, please. So we have identified two scenarios, and I'm sorry, maybe the terms we have used are not probably so widely adopted, but let's say first scenario is probably the most common. We have called it equal prefixes. So we have two routers. We can decide which one to use depending on the specific application. So basically, if I want to reach a destination on internet, I can use, for example, router A or router B, depending on the addressing plan or, let's say, on the requirements of my application. Basically, the mechanisms are defined in 7624, rule 4, rule 5, or the optional 5.5. You can also apply the conditional POs for deciding how to, let's say, select the source address and, let's say, decide, okay, this is the next stop I want to, let's say, to use for connecting to the destination. Okay, this is it. But there is another scenario, and probably we focused on the second one, which is the one that we named non-equal prefixes. Why that? For example, because there is a special case, a special requirement to steer the traffic, for example, to a dedicated site. So, typical example, walled garden. Other case, well, we want to steer the packet to reach a certain destination through a certain gateway because of specific requirements. For example, the packet loss or the latency provided by one of the upstream providers. How to deal with that in the multi-homing, multi-prefix case? Well, based on our analysis, the only solution available today is defined here. So we have to apply routing information options and let's say something that could change the default policy table, for example, through the HCP v6, which is defined by RFC 7078. To our knowledge, this is not so widely adopted. So that could create some cases. So how to solve this issue? And we can move to the next slide, please, John. Okay. We have identified one potential solution, but there is probably one caveat. So one thing that we should pay attention to, and I'm pretty sure that could also raise some concern or some criticism. So for example, the idea is that in the source address, in the, let's say, in the process to decide which is the source address to be used by a host, and which is the next hop we need to, let's say, to select to reach a certain destination, well, we have to define that source address selection comes first. I think this could be also taken for granted, but actually this is not the case. So if you read across the available literature, this is not always the case. There are points in different, scattered across the different RFCs where you see that next hop selection comes before source address selection. Clearly, we are open, as I said, to comments and criticism to this point. But if we, let's say, take this path, so we decide that source address comes first, and then we select the next hop, then we have the possibility to open, let's say, many more cases or mechanisms to solve the connectivity aspect when we are in presence of specific cases as the walled garden, or as we said before, the idea of choosing a specific path because of, let's say, application requirements. Next slide, please. Then we have also to take into consideration what happens when we have failures. So when we lose connectivity, for example. In that case, let's say to give a solution which is applicable to the selection of the right source address, so to drive the traffic through, let's say, the network to reach the walled garden, and to cope with loss of connectivity, we are proposing in our draft some modifications that we believe are not so, let's say, impactful on the existing RFCs that you see listed here. So basically, the idea is that clearly we have to agree upon the fact that source address is selected first, then we move to the selection of the next hop. This is point number one. Then we can apply something which has been already described, as I said, in different RFCs that makes sense in dealing with this aspect connected to multi-homing, multi-prefix. So clearly select a next hop that has already announced the source, let's say the prefix to which my source address belongs to. Then dealing with the deprecation of the prefix information options according to the specific case. So if we lose, for example, the source prefix, accordingly, we have to inform the internal network that something is happening. Touch also some other, let's say, RFCs according to the mechanism that we are going to define. Basically, the idea is that for multi-homing, multi-prefix in IPv4, there is a solution, which is typically based on private addressing and NAT. And we'd like to also find a solution to the same issue when IPv6 is used. So that we can move to the next slide, please. And I said, so we are open to any comments, feedback, even criticism. We are very happy to, let's say, to listen you. By the way, the analysis is open. So this is version 0. So anyone interested could join and be also co-author with us. Thank you. Any questions?
Yeah, I see. David?
David Lampotter. So considering that link local addresses are essentially free and abundant, I don't see any need to change the source address selection order to select a source address before the next hop, because anything that can be achieved by doing that can also be achieved by simply adding a new link local address on the router and choosing that as a next hop, and then choosing the source address to match that. So that seems to be a much simpler approach.
Okay. So as I said, I don't expect that everybody agrees, of course. Let's discuss it. If you are interested, we can have an exchange and see why we are proposing that. Sorry, I'm keeping it simple, but just for the sake of saving time for other questions.
Eric Klein, No Hats. I mean, I absolutely agree. If you have 8801 and you generate per PBD link local addresses to announce them, you don't have any problems here. You do have an implementation of 8801 is, you know, I don't want to say complex or non-trivial, but there's a lot to consider there. And some of those considerations are some of the things that I saw on the slides. So if you wanted to write a document that was maybe more in the style of all of the ink that was spilt in the MIF working group, that might be helpful for people who want to do 8801. But I think 8801 plus per PBD link local addresses and like this is, so it's done.
Okay.
Fernanda?
Couple of comments. You know, one meta comment is that, you know, I see that this document and, you know, also the previous document that you had authored on prefixes has a lot of overlap with work that this very same working group is carrying out with a working group document. So the work on the let's say prefixes that become stale is work that has been going on for about 2 years. A lot of it happened in basic ops. There's a remaining bit in Sixpan, which is the document that I presented before. So what I would expect is that the associated work with stale prefixes is done in that context. Otherwise, it's like redoing stuff that the working group is already doing in an individual submission. So that's one of my comments. The other comment that I have, I went through the document yesterday, and I see that this document is I don't know if it's mixing things that are like a topic on their own, or that is trying to do too much into the same document. For example, I read parts where there are discussion about the properties of IPv6 addresses, like what are ULAs useful for. That's a topic on its own. Okay, more than a couple of paragraphs as part of this document. There are other areas where the document tries to analyze scenarios for which there are operational workarounds. That's probably more for a document for basic ops than for Sixman, I would expect. Same for analyzing gaps where there are scenarios that you want to support, but there's nothing there to support them. Probably what I would expect there is a bit, if anything, a B6 ops document that analyzes the cases that you want to to address, analyze the gaps, and then do the standards work. And then that might require a reread on my side, but I got the impression that more than trying to tackle the the problem in in a generic way, there's a lot of analysis of super specific scenarios. Again, I might need to reread the document, but I got the impression that there's a lot of energy being put on specific cases, as opposed to trying to see the broader picture and figure what's missing here.
Okay, thank you. But let's say that, as I said, this is version 0.0, so
could I try to answer this? Because for overlap, I don't agree, because for overlap, we have really deleted everything which was really overlap in the previous draft. Yeah, previous draft was a big overlap, you're right, yeah. But this one, we have deleted everything which overlapped. They believe this one is just about multi-home, multi-prefix, which is specific topic. For that reason, overlap, I would not agree. For mixing things, maybe yes, maybe we need to think more about your comment that it's mixing things, it's very complex. Yeah, probably you're right. Thanks for your comment. We will think about it. And especially good your comment about ULA, that maybe ULA discussion could be deleted from here. We'll think about it. Maybe really ULA discussion could be deleted from this. Therefore, thanks for feedback. We'll think about it.
thank you, Edward.
Okay.
And for Eric, question, could I try to answer? Because I still believe that RFC 8801 is not enough, because if we will choose not properly initially next scope, then it would be too late to apply 8801. But we will take it to offline. I will prepare a more or less long message to the alias, and I will try to explain why 8801 is useful only after the source address is chosen.
Jelenkova, no heads. I'd like to second comment Eric made about PVD, because actually IETF has been trying to solve this whole problem for a while. I remember we have a lot of discussions. I remember IETF 2016 in Berlin when all these discussions started, right? And even then it was like PVD seemed to be like a proper way of doing this. So maybe if you think for some reason MPVD does not solve your problem, the document needs to have better problem statement explaining why exactly MPVD does not do, because I read it and I'm still confused why you cannot use MPVD and how basically switching the order of changing address selection would help you in this particular case, right? So yeah.
PVD is good enough after the proper source address is chosen. After this, PVD is good enough, no problem. It's compatible to PVD, but PVD itself is not enough. Initially, we should properly choose source address. Okay, we will try to explain it in different way and maybe longer. And okay, we'll think how to explain it properly why PVD is not enough.
Yeah, so Eduard, I suggest maybe just have a section in the beginning saying, this is what's going to happen with NPVD, right? And this is why it's bad. And this is a problem it's causing and how we need a new solution which do what we'd like to achieve, right? Because it looks like I'm not the only one confused. So probably, yeah, we need to clarify the things there.
And as we said already on previous slide, PVD is compatible. If we will properly choose source address first, then PVD is compatible. Previous slide. Among a list of algorithms which is possible to use, previous slide. PVD is applicable. It's not a problem to use PVD, but initially we should choose properly source address. Okay, we will try to explain it better.
Yeah, thank you.
Okay. Thank you.
Okay. Okay, CJ Light, Edward, the floor is yours.
Okay, this particular slide deck is a small one. Go next slide, please. Of course, we know we discussed many times already on the alias that there is a security problem that anybody could impersonate any other node on the link, because anybody could claim that particular MAC IP relationship is his MAC, and in such a way could poison the cache for other node, especially if a router is dangerous. Antitrust model has a general discussion how to do this. In my particular draft, I have referenced here, I have a more really detailed discussion how to really poison the cache for other node. But okay, it doesn't matter, because of course everybody understands that if there is no encryption, then it's possible to impersonate other node. Okay, it's a problem. Initially, it was believed that IPsec will help, but then it has been understood, okay, IPsec is for some reasons is a challenge, not suitable. Okay, fine. Then SAND and CGA has been prepared, and it's a good strong encryption, no problem. But okay, nobody accepted again, and I have an opinion that IPsec and CGA SAND has not been accepted because it's a key management challenge. It's public key infrastructure management, key management is a big challenge, which is, of course, if you have it, it's excellent. But if you don't have it, then it's not applicable. And especially one comment about CGA, initial CGA, that initial CGA was not as a separate solution. It was not possible to use it as a separate solution. It was a part of SAND. It was dependent on SAND. And just one reminder that initially CGA and SAND together, they connect public key to IP address. Okay, interface identifier, but it's IP address. It was connection between public key. It was not connection like in ND protocol between MAC address and IP address. What is possible to do? It's possible to use the same algorithm, the same mechanism which has been used in CGA, but it's possible to connect MAC to IP, the primary function of ND protocol MAC IP connection. And if we will connect MAC to IP by this simple CGA, even a little bit simplified, because in this particular document, CGA is a little bit simplified. For that reason, it's called CGA Lite. But it's in principle, it's the same CGA, it's the same algorithm which is used in Bitcoin, in blockchain, in CGA. It's again the same. And then the security of IP would be equal to security of MAC address. And MAC address security is good for some particular technology. It's good for .1x. It's good for Wi-Fi because we have encryption. And if MAC is protected by some layer 2 technology, then IP would be the same protected, because IP would be connected by effectively in very secure way connected to MAC address. Next slide, please. How to do it is exactly the same like it was for very similar, not exactly the same, but very similar, like it was for CGA. Initially, we prepare some block of information with some information like network name or time or nonce or whatever, which is needed primarily to for temporal addresses, for different stable addresses for different interfaces. It's to be compatible to all other things which we have for address. And then we do hash, connect prefix and mark do hash again. And after double of hash, we are trying to find the hash which will have some number of leading zeros. The draft itself has a discussion how many leading zeros is possible and how many leading zeros is more or less good security, and how it's a discussion is more accurate in the draft how to properly choose a number of leading zeros. But if it's not enough, then we do mining. We change nonce or change something in the initial information and loop again and do it again and again, and it's mining. But if you would like to simple security, not very strong security, that mining could be very fast. It's even possible for IoT devices. It's explained in the draft that it's possible even for such low computing power like IoT devices. If you would like something strong which would be really protected, okay, you could do mining long, or you could use stronger machine, even not the node itself, but you could use some offline computation. And then you will get some number of leading zeros. The trailing bits could be used for interface identifier. You could ask question, Eric.
Yeah, Eric Ving, Cisco, and in this case, Noet again. We are linking again the interface ID to the MAC address. Are we back to AU64 problem and lack of privacy?
No, because look, on this particular picture, it's good that you asked right now, because look, on the upper side of the slide, you see the block which has inside collision count, net name, time, nonce, other information. If you will put here, and definitely you will put here enough information, then you will get different, of course, interface identifier for your different logical interface, for your difficult physical interface. No, we will not break anything. I have analyzed carefully temporal addresses, stable addresses which are different for different logical interfaces or different network names are still possible. It's not a problem, because it's initially you will choose different information for generation of such addresses. No problem.
Okay. Thank you, Eduard. Another question now. Maybe you're aware that there is a Madinas working group. Then I put my AD hat on again, which is about randomize and changing MAC address. So typically, we will change the MAC address, and as far as I know, Windows 10 tend to change the MAC address quite often during a day, even.
Okay, but it would be like temporal addresses. If you will choose a low level of security, small number of leading zeros, then generation of new IP address, new interface identifier would be easy and would be fast. But yeah, it would be additional burden because it's additional mining. But it depends how difficult you will choose a security level, how difficult, how many number of leading zeros you will choose. If you will choose small number of leading zeros, okay, it's not a problem.
Okay, but it's worth mentioning in the draft, most probably.
Yeah, it's a good comment. It's a good comment. Yeah, thank you. Go next slide, please. For legal host, it would be extremely easy to check that some particular MAC to IP relationship is legal, because it's just one hash. Just one hash based on public information, and any other host will check that, okay, this combination is legal. Go next. If bad guy will try to break this, the bad guy, what bad guy needs? The bad guy needs the same interface identifier, but for different MAC address. It means he will change something in the source initial information. Then what he need to do? He need to do mining. But in his case, mining would be much more difficult, because in addition to some number of leading zeros, he will need additionally 60 trailing particular bits. 60 bits at the end should be exactly particular interface identifier. It means that 2 powered by 60 more hashes. It's extremely strong additional protection. It's again analyzed in the draft how strong it is and how it's comparable to Bitcoin, for example, how fast whole Bitcoin network could crash this, for example, how much time will be needed. Okay, go next. There is a little bit information which should be distributed, public information. One is hash type, and for hash type, I'm trying to use already defined option 39, not to invent something new. Of course, it's possible to invent something new if you believe it's useful, but my initial assumption not to invent something new. And additionally, I need digest of ID information, which I'm proposing to as a new option, as a new one additional option. Go next. I have analyzed more or less all other extensions for ND which we have, like optimistic ND, like Grant, like ND proxy, like all type of addresses, and looks like it's compatible to everything except a few restrictions which is put on this particular slide. The one restriction, because everybody is equal in this ecosystem, nobody could be restricted who is router, who is not router, everybody is equal. And for that reason, it does not preclude anybody to claim that he is router. Therefore, error guard or error guard plus is still needed. It's not a protection against router fake. It's okay. One a comment. Another comment, of course, it's not protection against DOS or DDoS, because anybody could generate many legal IP addresses and then spam everybody. Okay, it's DDoS is not protected, of course. And there is one rare case which is really could happen if a particular legal host is disconnected. His MAC and his IP is not available, then anybody else could try to use his MAC and his IP address. And if the low-level infrastructure, level 2 infrastructure, will accept his MAC address without authentication or with maybe breach, some problem with authentication exists, then because he will claim the MAC and MAC is not available, he will claim IP address because his IP address is just connected to MAC. And if anybody, it's low probability because server probably is always available, but for client, we don't so much care. That's it. Okay, Fernando, yeah, question.
The goal of this proposal is to prevent IP address impersonation, or what is specifically?
Yes. Because
now
the guy who the pair MAC to IP address, this pair could not be claimed by anybody else. Nobody else is capable to say, okay, this particular IP address is mine. I have different MAC. MAC to IP will be strictly connected by cryptography. It would not possible to break this particular connection.
But then you mentioned that, for example, this will obviously not, so what are the attacks that you have in mind? Because you're saying that, this will not protect against, for example, a node claiming router functionality.
Please go to slide 2. Slide 2. Slide 2. Yeah, 2. On the slide 2, on the left side, we have a discussion section 4.1 from ND Trust model. And in my draft, I have more detailed discussion how to particular poison the cache for any other node. And this is against this. This is against poisoning of the cache of other node, because on the other node, we could claim that this particular IP address is connected to different MAC, and then would be man in the middle attack.
Yeah, so in general, the idea of tying identifiers, from different layers together has generally proved to bring problems, unless you really need that. So it's entangled things that they don't really need to be entangled. If you want to, in a way, when we moved away from EUI 64, it had to do with that, like two identifiers from different layers tied together that they shouldn't. That aside, if in the same way you need RA guard anyway, why would you, for example, better implementing this as opposed to using ND inspection, for example, part of first hop security?
ND inspection, like Savi, for example, is good.
Yeah.
But it's supported just by a couple of switches. I mean, just one vendor, couple of switches. It has really low acceptance by the market.
Yeah, but you need array guard anyway, because, you know, in that case, I could, you know, as an attacker, spoof a router. So if you don't have array guard, I can attack you anyway. So
No. Array guard is very simple. It's not so complex. Like you'll do. Of course, if you will do ND snooping, full ND snooping like Savi, of course, then you could trace who is connected to which particular port, and you could keep security. But array guard is much simple. I mean, array guard, you typically point one port and say, okay, on this one port, check that ICMP does not have array, and that's it. It's very simple. Every switch supported, but not every switch support ND snooping, and for that reason, this particular ND trust model section 4.1 is still not protected.
Okay.
The big principal difference here is only one. Initially, CGA and SEND were connecting public key to IP address. Here is connection MAC to IP address. And for that reason, there is no need for public key infrastructure. There is no need for key management. And for that reason, acceptance probability by the market is much higher. That's it from my side.
Okay. Actually, I put myself in the queue. Jalinkova now has. I'm not actually exactly clear why you're saying it's only for disconnected node an attack could happen. What would prevent an attacker to claim MAC address and IPv6 address while node is still connected?
Because if it's partially true, but okay, if particular layer 2 infrastructure has two nodes which claim the same MAC address, would be flapping, and in this flapping, of course, you could catch some packets in this particular flapping, but it's a layer 2 problem. If you have in some particular layer 2 domain, it's not normal situation anyway for layer 2 if two MAC addresses connected to one layer 2 infrastructure. For that reason, it's problem anyway.
So basically, you're saying you would rely on monitoring and alerting in this case to detect an attack, but it's not actually prevented, right?
You could say this way, yeah, but maybe not just this way, because additionally it's flapping. I mean, interface MAC address and interface would be up and down, because MAC address would be duplicated. Duplicated MAC address will not permit the host to operate anyway. The host probably will call support and ask for support because he could not work.
Well, I guess in many cases, scenario with stolen addresses also can be detected by monitoring and complaints. Yeah, but I guess we are talking about preventing the attack instead of like reacting to it. So actually, my second question is, if your hosts are kind of in untrusted domain and you don't trust them, wouldn't it be better just perform layer 2 isolation and solve all this problem forever? But if your hosts are sitting in the same broadcast domain, they're kind of in the same trust zone from security perspective. So I'm not sure how big the problem is actually in like real life.
In majority of cases in real life, Wi-Fi, for example, or Ethernet switching infrastructure, data center, enterprise, whatever, we typically don't have isolation at layer 2. Typically, one VLAN, for example, everybody could connect to everybody. I'm not sure how many, probably very small number of cases we have in the world. There are people who really implement something like private VLAN, for example, or filtering on Wi-Fi. yeah, it's possible. It's possible to restrict that only Wi-Fi station could go only to uplink. It's not possible to send packet from one Wi-Fi station to another Wi-Fi station. It's possible. It's possible to do filtering, but typically it is not done. Typically, especially in data center, but in enterprise networks, typically it's possible inside one VLAN, everybody connect everybody.
Okay, thank you. So any other comments from the room or from remote participants? Okay, so I guess we shall continue that discussion on the list. And thank you, Eduard.
Thank you.
And then okay, the next presentation is expert of segment routing information in IPFix. Okay, let me get the slides.
Perfect. Good afternoon, everybody. Thomas Graf, Swisscom, on behalf of the authors. This is about enabling insight in SRv6 forwarding plane by adding segment routing dimensions in IPFix.
Thomas, may I ask you to be close to the mic or just
Sure.
hold it because I suspect people remote mic. When you turn around, people might
Perfect.
not hear you. Okay.
Thanks a lot. Next slide, please. So speaking as a network operator and looking back from a migration between MPLS and MPLS SR, we know that data plane visibility is very important during migration. And currently it's missing in SRv6, and we're trying to address that in this document. We want to see as a network operator how much traffic and if traffic is being forwarded or dropped towards a segment identifier. We understood that currently SRv6 is already being deployed by network operators, and also the first ones started to do migrations from MPLS to SRv6. The main data is coming from the segment routing header, which is defined in section 2 of RFC 8754. Next slide, please. So the elements coming from the SRH header are, for instance, the segment's left field, the tag field, and the flags field, while other informations, for instance, the SRH active segment IPv6 type is basically describing from which routing protocol the active segment is coming from, while the SRH segment locator length and the SRH segment endpoint behavior also are information coming from the control plane, basically describing additionally the segment routing, the SRv6 dimensions. Next slide, please. There are different ways how to expose the segment lists. One is by doing the decomposition on the network node with the SRH segment IPv6 basic list and the SRH segment IPv6. While the other possibility is to maintain the SID list completely and expose it in one element in the SRH segment IPv6 list section. While the last possibility is actually to expose the entire SRH header in the SRH section IPv6. Depending which solution is being chosen, there are different implications, especially in terms of scalability, which are described in the operational consideration section. Next slide, please. This draft was already being presented at IETF114 to Spring and Ops AWG. We received various feedbacks. We all addressed already all open issues and also double-checked the IANA consideration section with the IPFix doctors. We added per request also in the operational consideration section a section how to decompose the segment list when compressed SID is being used. And we added, therefore, the SRH segment locator length and the SRH segment endpoint behavior in the draft. We aligned the naming of the IPFix entities from the RFC 1712, updated the SRH flags IPv6 registry, and have now in the addendum section examples for all the different data template, option templates, and data records. Next slide, please. So the next step is we have currently two major vendors which validated technical feasibility and working on implementations. INSA University in Lyon is working on running open source code in VPP. We will be able to show that at IETF114 hackathon. We as authors believe that the document should progress quickly through IETF to avoid private enterprise code points being used in SRv6 deployments, and therefore requested at IETF 113 at Ops AWG adoption. Looking forward for comments, feedback.
Anyone? Oh, Eric, you like to say something?
I guess I just wanted to ask, to be clear, you're not proposing any changes to 8754?
Correct. There are no changes. We are proposing changes to RFC 1711, which is IPFix.
Yeah.
Okay, so I see no comments here, and I guess it's just for information, right? So no action requested from this group, except for, I guess, review comments will be appreciated if you're interested. Okay,
Exactly.
thank
Thanks
you
a
very
lot.
much, Thomas. Okay, and topology identifiers in extension header.
Hello, can you hear me?
Yes, we can hear you. I'm starting sharing your slides.
Okay. This document is about carry topology I identify in IPv6 extension header. Next page, please. MT and FlashEcho can generate multiple routing plans. Currently, to distinguish different routing plans, MT and FlashEchos are manually identified using different IP addresses in that packet. We need to plan different IP addresses for each MT and FlashEcho, which increases the network development complexity. The IGP protocol needs to advise more IP addresses, which also brings scalability problems. The application of network slicing also increases the number of MT and FlashEcho in the network, which increases the impact on the network. Because an interface may belong to multiple MT or FlashEcho, this problem cannot be solved by associating separate interfaces with different MT and FlashEchos. This document introduces a generalized approach to allow different MT or FlashEchos to share IP addresses. A new hop-by-hop option of IPv6 extensions header is defined to carry the topology identifier, which is used to identify the following table instance created for MT or FlashEcho. Next page, please. This is an example for topology identifier. In this scenario, links with different colors belong to different FlashEchos. Green for FlashEcho 128, blue for FlashEcho 129, red for FlashEcho 130. All FlashEchos share the same node IP address. For each FlashEcho, each node congregates an SPF tree independently and generates an independent lib or fib. Next page, please. This document introduced a new hop-by-hop option which carries topology identifier. Each topology identifier is mapping to a folding table. Topology identifier is encapsulated on the head node. The mid node makes the folding table selection based on the topology encapsulate. This then look up the folding table and send the packets. Next page, please. That's all. Any comments are welcome. Thank you.
Peter, you're first in the queue, I guess.
Peter Pshenak, Cisco. So when we designed the Flex Algo technology as such, one of the strong requirements was not to require any specific data in the packet. We tied the Flex Algo with the forwarding construct in a packet, which is either SRMPLS label or an IP address itself, which is the SRv6 case or IP Algo case. So what you are trying to do here goes completely opposite what we are trying to do with a Flex Algo. And a bit of a history here, an MTR has been tried and failed miserably because of the need to classify the packet on every hop. This is exactly what you are doing. I'm not sure this is a good idea. Thank you.
Eric Veng, Cisco, no specific hat. I simply repeat what I said for the previous draft for the VTN ID. I don't mind, and don't discuss the Flex Algo thing, right, because I'm not an expert there. But having a way to mark or color the packet is interesting for sure, but make it generic, not one per protocol. Thank you.
Hi, Suresh Krishnan. So just a question. So is this the host putting in the information for the routers to look up on what routing table?
Hello, Suresh. Can I take this question?
Yeah, the question was who's putting in this empty info? Who's like putting in the hop by hop option in there? Is it the host that is initiating the packet?
Yeah. Sorry. Thanks for your question. In fact, this is the ingress router of this MPRs of the tunnel. I mean, so the ingress router encapsulated the topology information in the forwarding data plane, not the host.
Okay, so I think like there's something that you probably need to do a little bit more, like the security stuff in here, the properties of this is like very scary that you determine like, how the router looks it up. So probably you need to spend a little bit more time on the security properties of this before it goes forward. But I do, if the people like, Peter was here, if this is something that's not signed off by the eventual consumer of this, we need to discuss that first. Thank you.
Okay.
Okay, Zhenbin, you are next in the queue.
Okay. Zhenbin from Huawei. I would like add some this the comments regarding the Eric and Peter's the comments. The first one, I mean the Peter's the opinion. In fact this is explained in the slides because according to the current design of the Flex Algo, it need more IP address for the different topology, so that it will consume more IP addresses. So here we introduce a new method can share this the IP address and also take the advantage of the IPv6 to encapsulate the topology ID to identify. So this is just the solutions concept. Second one regarding the Eric's concept, I comment. I agree with this one. In fact, in the network, in the TIS working group, we propose one draft generalized IETF network slicing, we are discussing about if the Vtn Resource Id can be generalized to represent the topology or not. Yeah, we ask this the comment. Okay, that's all.
Joel Halpern, Ericsson, I'm sorry, but this doesn't add up. The fundamental problem you stated was, well, we need a different IP address for each topology the end node is participating in. From where I sit, that's a benefit, not a drawback. This is IPv6. We're not short of end node IDs. Bob laughs. It works. Whereas you want to introduce a new extension header that we have to take into account in forwarding at every hop. This is a very difficult solution to a non-problem. Please don't.
Tomasa?
Yeah, Tommaso Pecorello, University of Florence. I'm sorry, maybe I missed something, but if I remember correctly, an extension header cannot be added by a router, can be modified by a router, but not added. I don't know. Maybe I missed the RFC.
Okay, Zhenbin, because in the router, because the packet will encapsulate the tunnel header. When encapsulates the tunnel header, we can add the information with the topology, add the topology information with the new tunnel header. I think that's different from the host process.
I will try to read your RFC and see if I see anything that I missed. Thank you.
Okay.
Actually, I'll add myself to the queue. No heads, but I actually agree with Eric that we kind of see a lot of different drafts which suggesting different kinds of identifications related to network slicing, APN, and so on. And I'm not an expert in the area, but I think it would be a good idea to consider having one thing which can be reused instead of standardizing 5 million different options. It's not like commenting to you, but I think people maybe we either here or in some other working group need to consider how to solve this problem once and for all. And I see Eric is looking to the microphone.
Yeah, I was just going to say I sent email to the responsibility for T's about the status of the network slice document there. It would be in hopes that we could eventually get a conversation about network resource partition identifiers and all these other sort of identifiers. It's not clear how many of these we actually need, and but we haven't closed on that conversation yet. But if six-man chairs could always send a liaison statement to the T's chairs and ask about those kind of things.
Cool, thank you, Eric. Okay, we have 4 minutes, so I'm Jean-Bin, do you reckon you can give us overview of generalized channels in 4 minutes?
Yeah, yes, I'm okay. Very
Okay,
quick.
I'm sharing the slides then.
Okay, so this is Zhenmin from Huawei. My presentation is generalized IPv6 tunnel. Okay, next page. Okay, so here we propose this the challenge because we know now we have the many types of the IP tunnels, such like the GRE tunnels, VXLAN tunnels, and also have many variant of these IP tunnels. All these tunnels have the format with IP source address and IP destination address. So at the same time, we also have many new features. Even this has been proposed by Jane in the previous comments. We know now we have the network slicing, and we have this APN, we have the alternate marking, we have the IOM. All these new features, we need the new encapsulation, and the new encapsulation has been defined and being defined for the IPv6 encapsulation. So now we have this the challenge to how we define this the encapsulations for these IP tunnels. So this has the challenges. Okay, next page. Okay, so here propose is a challenge. So that's the first one. If we define this the new features encapsulations for all these IP tunnels, we have the huge standardization work. And the second one is difficult to keep the consistency between the IPv4 and the IPv6 because it has been recommended the new work is to be done based on the IPv6. Third one, I mean, so there's some this the function redundant because, for example, if we use the IPv6 for the IPv6 for this IP tunnel, so that's the IPv6 flow label can be used for ECMP, but you know that in history, the IP tunnels, some IP tunnels use the IP UDP port number for the ECMP. So there's the repeated functionality in the same this tunnel header. So this the last one, so that's we can difficult to extend based on the existing format because some IP tunnel has their own header. For example, VXLAN and GRE. But we also have some these tunnels such as the IP in IP. There's no their own header. So that's it's difficult to have unified this the extension if they to support the new features. So we next page.
Sorry, we have just 1 minute, so can you just
Yeah.
quickly summarize? Yeah.
Oh yes. So here we just we have proposed this generalized IPv6 tunnel header. So we think that for all these IP tunnels, we you have the generalized IPv6 tunnel header. That means the IPv6 header and all these the new features and all the existing IP tunnels functionality can be encapsulated in the IPv6 extension header. So means there's no need necessary to define the new features for all these IP tunnels. That's the concept. Okay, that's all.
Okay, thank you. I don't think we have any time for discussion, but I guess the draft is in the writing working group as well, right? So, okay. Thank you very much, everyone. See ya in London. Please read the drafts. Please comment on them.
Okay.
Thank
Yes, thank you all very much.
Okay. Okay, thank you, Jen. Thank you, Bob. Okay, bye.
Take care.